Good afternoon. My name's Alan Brown. I'm the Chief Technology Officer of Aptitude Global. I appreciate you taking the time today to join my session on fighting financial crime efficiently with entity resolution and graph technology. So a quick introduction to Aptitude. Aptitude was established in 2014 by former MDs of technology investments at UBS. We are specialist consultants in delivering highly automated solutions to across multiple sectors. We specialise in financial services, pharmaceuticals, energy and utilities, and the legal sector. We have quite a lot of experience in fraud and financial crime, building solutions for tier one banks in the UK. And we also have, as Neo4j partners, quite deep experience working with Neo4j, delivering solutions across Customer 360, fraud, financial crime, supply chain, and data governance. So the agenda for today, first and foremost, we're going to discuss the industry challenges. So the impact of fraud and financial crime, the challenges we face, how technology can help, and how specifically entity resolution and graph technology can help, and why they are so important. I'll give you an introduction to Aptitude's data intelligence platform, which make use of some of these technologies. And I'll go and do a live demo for the last sort of 10 minutes of the session, so you can get a feel for these technologies. So the challenges. Fighting financial crime. Through my experience, I would say that the single biggest challenge that we face is around poor data management, poor data governance, and ultimately a lack of data quality. What we see quite regularly is large levels of duplication within customer systems, no mastering of data, a lack of data controls, inconsistent use of reference data, and also a lack of external monitoring of trusted sources of third-party data. So, customers not proactively updating their details, and that information obviously, becomes out of sync. And what we find is that customer details quite often is very much out of date. And that lack of data control means that teams within the fraud and financial crime, domains are often working, I guess, with two hands tied behind the backs. They're working with difficult situations with poor quality data, a myriad of source systems and data silos, that are not connected together. And this is then often compounded by poorly integrated processes, so very manual processes, copying data from one disconnected system to another disconnected system, which creates quite repetitive and unfulfilling work. There is also very much a buy culture where, companies often elect to buy products rather than to build an integrated architecture within, their organization. And that often results in, again, these sort of poor, disconnected processes where you're having to manually copy data between your transaction monitoring systems and your KYC systems and your investigation systems and so on and so forth. And we see these manifest in different ways within organizations. So, for example, I've got, specific experience of some banks where I've seen alerting capabilities that are have less than 0.1% accuracy. So 99.9% of alerts being raised are inaccurate. They're not valid alerts. And consequently, again, this just leads to the frustration within the fraud and financial crime teams that they're dealing with repeated alerts against possibly the same individual day after day. And there's a lack of automated discounting that occurs there. Companies often spend a lot of money on consultants to try and come in and address these problems. They buy a lot of software to try and address these problems, and that introduces licensing costs, infrastructure costs, and then the integration costs of trying to connect all these systems together. We're also seeing quite significant regulatory fines. And the FCA, for example, issued £1.3 billion of fines in the last 4 years, and over 60% of these are financial crime related. There's global fines of over $5 billion in 2022 alone. And unfortunately, fraud is still occurring. Now, UK customers lost $1.2 billion in fraud last year. In one single case, the Department of Justice in the US cracked down on $2.5 billion of healthcare fraud. So you can see that this is quite a significant challenge. I would say the trend is probably slightly improving. I think if you look at year on year, the volume of fraud is probably reducing. I think that is due to technology enhancements. So I think we are making progress, but we can't afford to stay still. The criminals are smart. They know your processes, they know our processes, and they're constantly evolving their tactics. So we have to stay ahead of the game. And this is why technology is very, very important. We have to invest in technology, and specifically, in my opinion, this is where graph technology can help. Graph analytics and graph technology specifically are fantastic at helping detect complex patterns. And when you think about the scenarios within fraud and financial crime, detection of, for example, transaction layering for money mule networks, sanctions evasion schemes, synthetic identity rings. These are all things that are very network based. Okay, looking at the connections between individuals, the connections, whether that be transactional connections, familial connections, relationship connections, etc., account connections. These are all things that are very, very easy to represent within graph technology. And it's also excellent for allowing us to identify relationships with risky connections. So we can bring in lots of sources of third-party data, sanctions lists, PEPs lists, criminal watch lists, fraud lists, etc., where we've got known confirmed cases of risky individuals and companies, and be able to assimilate that within your graph technology in order to identify those risky connections. So graph technology is absolutely critical and fundamental to the work that we do in fraud and financial crime. However, there is a barrier of entry there. So there's assumption that people know how to integrate or interrogate a graph, that you do need those technological skills. And this is the problem when you're trying to introduce graph technology to fraud and financial crime teams, that these people are often used to working with particular workflow tools or within spreadsheets. And graph technology can be a little bit alien to them. And this is where graph visualization software really comes into its own. It lowers that barrier of entry. It gives them an easy interface in order to interact with the graph, in order to conduct investigations, manage their alerts, complete suspicious activity reports, interrogate a potential fraud network. And they can all do that, through really, really nice, simple to use graph visualization. So the combination of graph visualization software and graph technology, absolutely fundamentally, is one of the critical tool sets for improving the efficiency of fraud and financial crime detection. So I talked a lot about integrating third-party data, and this leads me on to another important topic, and that's entity resolution. How can entity resolution help us improve the efficiency of fraud and financial crime? And entity resolution, first and foremost, actually, what is entity resolution? Entity resolution is the ability to identify where multiple records, either from the same or from different data sets, are referring to the same real-world entity. Okay, so it's very much a powerful integration tool. Allows us to take multiple records, data sets together, and identify whether they're referring to the same person, individual, company, vehicle, drug, whatever the real world entity is, and identify whether they are, first and foremost, are they not a match? Are they completely different entities? Are they possibly related? So they have some shared level of attribution. So, for example, maybe they are, they have the same address, but they have a different name and date of birth. So perhaps they live at the same address. So there's a possible relationship there. They're possibly the same. So they share some level of attribution. Maybe it's the same name and address, but they have a different date of birth. Now that means they may be the same person, but they may not be the same person, depending on how similar that date of birth actually is. Or on the last cases, they 100% we're very confident that they refer to the same real world entity. And the ability for us to do this gives us a really strong capability to integrate our data sets, to identify the relationships within our graph. So when you start to combine entity resolution with graph technology, you have a really, really powerful superset of technologies that can enable us to start to bring together really complex sets of data into a single graph environment. And when we start to overlay that in the context of financial crime, you can see here some very clear examples. We've got our internal data in terms of a customer risk assessment process. We want to validate their nationality. So we bring in our internal data, we bring in a verified, trusted source of third-party data. And entity resolution allows us to bring those records together and say, these two records refer to the same real world entity. This one tells us that it's a UK national. This one tells us, but actually we think this is a Russian national. They'll have different risk scores in your customer risk assessment process. And that allows us then to feed that in and make a decision. Maybe they need to go for enhanced due diligence, and without the ability to perform that confident match between your internal and third-party data, that becomes really difficult to do. Similar scenario here. If you bring in a sanctions list, and I'll give you an example of this when I do the demonstration today. If you bring your sanctions list together with your internal data, entity resolution gives you for free the ability to say this person is related to this company or individual on the sanctions list, and you've got the confidence there to use the explainability element of the entity resolution algorithm to say we're confident this is a match, and again, that really empowers your decision-making process when it comes to risk assessments. So how do you go about implementing entity resolution in the context of a graph-based solution? So you've got two sort of clear choices here. You can either build your own solution, or you can buy an off-the-shelf product and try and integrate it into your tech stack. Now, we have gone through the approach of both. So I wanted to share today our experiences of trying to build entity resolution versus working with technology partners to try and integrate that into a solution. And this will hopefully give you a flavour of what to expect if you were to undertake this process of integrating entity resolution into your solution. So you can absolutely build it in Neo4j. We've tried this, so you can use a fairly rudimentary approach in terms of record matching within Cypher. You can utilize graph data science. We can use things like similarity algorithms such as Levenstein or Jacquard, and we can combine that with weakly connected components, and we can use graph embeddings and link predictions. So there's lots of different, quite well documented approaches to building entity resolution solutions within your graph. We can also utilize things like other programming languages. We've used PySpark and made a combination of LSH, locality sensitive hashing, to identify clusters of data, then again use similarity algorithms such as Jacquard and Levenstein, and then push that data back into Neo4j, where we've used weakly connected components in order to create entities. So there's some fairly well documented approaches to how you would do this. The benefits of the build is you've got unlimited customization, no additional license costs. It works quite well for simple cases. You've got very explainable or predictable results because you're doing just record matching. On the cons, it's hard. It is really hard. If I'm being perfectly honest, the build effort is really high to try and obtain what I would even describe as being moderate results. You have obviously the level of customization. You can choose your algorithms, you can choose your thresholds, you can define your rules, but it does take time and it does take skill. It takes technical skills, it takes data science skills, and it can be complex to try and build in complex solutions like real-time, multilingual data sets. These are all things that are quite hard to do in the context of building your own solution. The alternative is to buy a solution. So we work quite extensively with Sensing. We've integrated this into a solution. I'll give you a demonstration of Sensing today. Sensing is a pre-tuned entity resolution engine. You integrate via the Sensing API into your solution. It's hosted, so it's internal to your own solution. So it's not a SaaS offering as such. What we then do is we integrate it with our solution. We push our results to Neo4j. So when you combine entity resolution and graph technology, that allows you to build a very explainable solution. And again, when you integrate that with your visualization technology, that combines the technology set that allows us to have the data integration capability, the explainability, and the visualization. The benefits of buying a solution is obviously a quicker time to market. You don't have to build it and define it and configure it in the same way that you do with your own in-house solution. We think there's a lower cost in that respect because the build effort is quite expensive. When you consider your lower implementation time. Sensing is self-learning, self-correcting, and real-time capable. To try and build that is quite complex, and the Sensing engine has this out of the box. So it uses what's called entity-centric learning, which is the concept of it's reevaluating the data as it comes in on a daily basis or a real-time basis. That entity resolution that isn't a one-time activity. Data changes, and consequently the results of your entity resolution process may change. So you have to have a solution that will take into consideration the fact that your data sets are changing. It's also pre-trained, but it's also multilingual, and this is very useful if you're operating in multiple jurisdictions. So, for example, when we're doing work with MENA clients, and we've got data sets that are coming in, perhaps we have data sets that are in Arabic. We can still compare those data sets to data sets in English or in Spanish or in French without having to do any standardization or transformation. So again, this is something that comes out of the box. You don't have to do the standardization around addresses and things like that, or names or formats. This is something that your engine the sensing engine can take care of, and again, that just reduces your implementation effort when you can compare this against your build situation. There are cons. There is a learning curve for customization. So because it's out of the box, it comes with predefined rules. If you want to customize that, then there is a little bit of a learning curve there. The entity-centric approach is more complex than record matching to explain, but it is more accurate. And what we'll show you as part of the demonstration today is how we have created the concept of explainability around entity-centric, so that we can negate that potential negative there. And obviously it incurs a license cost. But again, when you compare this to implementation costs, we think that the overall total cost of ownership of a solution when you buy and integrate is less than building your own. So I'm just going to take you on now to Aptitude's data intelligence platform, which will demonstrate some of these capabilities that I've just described. Aptitude's data intelligence platform. This is a reference architecture. We've implemented this with a number of clients now across fraud, financial crime, and some other domains. But effectively, this is a reference architecture for a data platform that can be used to support these types of use cases. And there is a standard pattern, I guess, that we follow. We have the ability to ingest data, whether that be structured, unstructured, internal, external data, semi-structured data. You have to have the ability to bring that data into your environment. Apply modeling techniques, because if we're going to build a graph, we have to model the data in the appropriate way. This may be industry standard models, such as the follow the money data model, which we have implemented as part of our solution. I think there's another session later today that I would definitely recommend that you attend with the guys at Open Sanctions, who will be talking about follow the money, which is a really excellent resource. So that's something that we have implemented into our approach, as well as data quality and entity resolution. So these four building blocks provide the foundation to then go and provide those analytical and operational use cases on top, such as fraud detection and fraud investigations. So here is the architecture of the demonstration that I'm going to give you. So this is you can see here on the left-hand side, we've got our internal data and our external data. We've integrated data from a number of different data providers just for demonstration purposes. So we're working with Diligencia, Experian, Open Sanctions. We brought this data together into a graph via ingestion layer. We're using Kafka and Python and REST APIs, but we're completely agnostic. This doesn't matter how you get your data into your environment. Ultimately, what we'd expect is that we bring the data into a centralized data lake or lakehouse architecture at a point where we can then assess it for data quality, which you can see in the top there. We can transform it into our target data model and load it into the graph, which you can see here as it moves through our REST API layer into Neo4j. But in parallel, and this is the interesting part, we load the data into the graph, but in parallel, we push it through entity resolution. And what Sensing is doing here, Sensing is identifying the relationships between the source data. Okay, so it's resolving all of the source data and determining which records in all of these different data sources are referring to the same real-world entities. And what we then create here through the Aptitude connector that's listening for changes in entity resolution, we're publishing some new nodes, some Sensing nodes into the graph, but we're publishing the relationships from those back down into the source data. Okay, so that is effectively building a metadata layer on top of the source data within our graph that explains how all of the data within our graph relate to each other. And that's the really interesting part of this, and you'll see this in action as part of the demonstration. On top of all of that, we have Linkurious. So this is the visualization software that I'm going to demonstrate. And again, this allows us to clearly show the benefit. What we've actually done is integrated Linkurious and Sensing and Neo4j through a series of connectors and plugins. And again, just to show how the benefit of combining visualization, graph technology, and entity resolution can empower your fraud and financial crime journeys. So I think we're ready to go into the demonstration. What I'll do first and foremost is I'll demonstrate the concept of explainable entity resolution in the context of KYC. I'll show you how we can identify a politically exposed person, and then I'll show how we can identify links to a sanctioned company. And this is all through Aptitude's data intelligence platform. So I'm going to jump into Linkurious. So this is the Linkurious sort of landing page. When you open up Linkurious, what you have here is some saved visualizations. I'm going to show you the alerting capability next. But the first thing I'm going to show you here is just a saved visualization that I have, just to explain how sensing works, how the entity resolution process works, but also how we've created the concept of explainable entity resolution within this technology stack. So what you can see here is this individual. This is, I picked somebody a really difficult name to pronounce, just to put myself under a little bit of pressure. Shalambos Stylianos Chirkali. Now, this individual, this node here was created by the Aptitude connector connecting to sensing. So this is a sensing node. And what it's connecting is lots of different source records from different source systems. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Different versions of this individual from Companies House, from Experience Business View, from our customer database. And what sensing is saying is, look, these all resolve to the same entity. So this is a concept of entity-centric entity resolution. So it's created this entity and saying, these are all the same person. Now, what we want to prove here is that's the case. You know, so the first question you'll ask is, how did sensing determine that they're all the same individual? So what we've created here is a plugin. Now, this is part of the Linkurious capability, is that you can create a plugin, which is effectively a small JavaScript application that you can run on the Linkurious server. And what it's doing is it's calling the sensing API with the entity information from the graph. So it's pulling it from the graph. It's got the entity ID somewhere in here. You can see here, calling the sensing API from the plugin, bringing the data back, and it's basically saying to sensing, why have you resolved this entity, and what are the connected source records, and what are the scores that you have applied in terms of the matching? And we bring this back and we visualize it within the Linkurious UI. So I hit explain entity resolution. It launches a small React application, which is pulling back the information from the REST API, the sensing API. And from within here, I can now see this data in a tabular format. I can see this is a person node. I can see lots of different data source records for this individual. And what I can do is just compare all. And this brings a very easy to understand tabular format that shows, you know, what attributes were used for matching, what score was achieved as part of the matching algorithms that were used, and where there was gaps in the data. If there was any mismatches, you would see these in red, but this is a very highly matched data set here. So they're all sort of 100%, 95%. And you can see, you know, that this is a much easier way to try and explain, you know, the reasons behind the entity resolution process and the matching that was performed. So taking that information, what I can then do is show you how we can use this in the context of fraud and financial crime. So I'm going to show you Linkurious's alerting capabilities. We have an alert here. I'm going to show you the alerts dashboard, and I'm going to come into PEPs and sanctions. So I've created some here. Now, alerts within Linkurious are effectively scheduled events. There's effectively cipher queries, we call them models, that sit behind here, and it executes the cipher queries against the Neo4j database on a periodic basis. We can do it every 5 minutes, 5 hours, 5 days. And the results are returned back within these alerts, which we can then, you know, give access to investigators to investigate. So the first one I'm going to show you here is politically exposed persons. So I'm going to pick one at random. I'm going to pick Mohammed, another name that's going to be difficult for me to pronounce, Ben Shaboon. And we can see here that this a sensing node has come back, and we've got four source records that are linked to this sensing node, so the person entity. We've got one from Companies House, one from Customer Database, and one from Experience Business View. And this last one here is from Open Sanctions. Now, this is effectively the Open Sanctions record here is saying this is a politically exposed person. We can see that this person is the Director General, former Finance Minister in Morocco, and the topic is PEP. So we're able to show here that at least this is a politically exposed person node, but it has mapped to 3 of the other records within our data set. Again, what we can do here is just run explain entity resolution. We can compare all. And using this information, what we're trying to do is build the confidence that this match is actually correct. That this record for Mohammed Ben Shaboon is the same person, the same real world entity as the one in Companies House, the one in Customer Database, and the one in our Experian Business View. And again, we can see here we've got date of birth matches between 3 of them. We've got a nationality match across all 4, and you can see here, I mentioned we didn't have to do any standardization. So MA automatically translated to Moroccan in lowercase, which translated to Moroccan in uppercase. And you can see a very, very strong match across all these details. So again, it builds a confidence for the user, for the financial crime investigator, for the for the analyst to say, I'm confident this alert is genuine and this is a real link between our customer database record and these other authoritative sources of this information, and then I can make a contextualized decision against that. And again, you can see here that this is agnostic of the language. So if this record was in Arabic, we would have still managed to match this on the basis of the the internal capabilities of Sensing. So a couple of minutes to go. Last one I'm going to show is Sanctions. So a link to Sanctions, a link to a sanction company. Again, let's just pick one here. Now, this is an interesting one. So this is basically looking within a company's network and saying, are there any links within 3 hops to a sanction in the open sanctions data set? So what I can do here is these nodes aren't connected. I can run a find shortest path query within Linkurious to show me how they actually relate. So what I can see here is that Al-Qadar and Brom LLP link to a sanctioned entity called GMI Projects via an address. Okay, so there's no obvious other relationship here. I can expand, I can expand out the graph here. I can expand out this. I don't see any other connection other than the address. I can see the sensing nodes that have been created. So that leads me to think, well, the only thing that's connecting these guys is the address. Is there anything interesting here? I can run a Google search just to see, is it a formation agent? Or at that particular address, you can see here, companies made simple, 20 Wenlock Road. That would explain why we have multiple companies at the same address. That's going to be quite common if it's a formation agent. You're going to have several thousand companies at that address, and maybe that's something that we would just dismiss on the basis of of no real linkage between those entities. Okay, so I have a minute and 40 seconds left. Let me just see if there's any questions. Let me just check. Try to find where the questions are. I can't see them. Any? Oh, there. Is there any specific known for approaches to bring down FP in alerts? Is that false positives? Okay, yeah, that's a good question. So there are, and there are actually technologies. There's products in the market that have been using artificial intelligence and machine learning approaches to try and bring down false positives in alerts. So it's certainly something you can do. One of the approaches that we have within Linkurious is we're actually able to combine alerts that are linked to the same individual or the same case as well, so that we're not seeing, like, for example, if there's 100 alerts raised, but they all relate to the same person, then we can actually aggregate them into one single alert, which obviously reduces the volume of alerts. But there are techniques out there, but they're generally machine learning techniques that I'd be happy to discuss in more detail, that can learn based on the attribution and the information that's raised within the context of the alert as to whether that is indeed a genuine case or not. Okay, I think that's us. So again, thank you very much all for attending, and hope you enjoy the rest of the conference.